Hello, good morning everyone. Now, my dear students, this is my second video on Haloalkanes and Haloarenes. In last video, I discussed till the topic nomenclature. Today, I am going to start with the topic nature of carbon halogens bond. Students, please try to follow the NCERT book because in board all the questions are coming from NCERT only, right? And whatever the material or the content you see on this screen are actually from the NCERT textbook. So please try to follow the NCERT. Maybe there is some problem in the video regarding the visibility. Okay, so try for that. So student, in the CX bond, first of all, I want to discuss about the nature of the constituent. See, halogens are more electronegative than carbon. So, carbon acquires partial positive charge, and whereas the halogen bears a partial negative charge. You can see from this in the given content. Now, since the size of halogen atom increases as we go down the group in the periodic table, and fluorine atom is the smallest and the iodine atom the largest. Consequently, the carbon halogen bond length also increases from carbon fluorine to carbon iodine, right? It's very simple. Bond length is depend upon the size of the atoms, right? So here carbon is constant, but if you see the variable one, that variable atoms are halogens, and in halogen when we go down the group, then their sizes increases. So when the atomic size increases, as well as it affects the bond length. Now dear students, in class 11 also we discuss about the bond length, bond enthalpy, right? If bond length increases, then bond enthalpy is going to decrease. I will show you a table where the bond lengths are given as well as bond enthalpy. So here from fluorine to iodine onwards, the bond length increases, and when bond length increases, bond enthalpy decreases. As well as in the last column, the dipole moments are given. You know, dipole moment is related to the more electronegative atoms towards the electropositive, and we already completed in class 11 that the dipole moment is the product of charge and distance. So you can see from this table also, the highest dipole moment is shown by chlorine, right? CH3Cl, right? And lowest in CH3I. So these are the table. The questions are based on like increasing or decreasing order of the bond length or their bond enthalpy. Such kind of possibilities are there. Okay. So after this discussion of the nature of bond and the nature of atom, that what kind of charge they appear on it, then we are going to discuss with the topic, or we are going to start with the topic preparation of alkyl halides and aryl halide. Okay, so in this preparation part, first of all, I am going to start with the topic preparation of alkyl halide from alcohols. Now student, listen one point very clearly. In organic chemistry, there is one very simple profit we can say. Some of the methods which we are using in the case of preparation, they are going to be used as a chemical properties, right? Means the chemical properties of one group can be treated as the preparation of the properties of another. Okay, so such kind of things are possible. So if you learn in a proper way, then in the next chapter, if the topic is going to repeat, so it's not going to be difficult. Okay, so try to learn or complete the chapters or the content in that particular manner, that it's going to be helpful in the next chapter. Okay, similarly, like I already discussed about the classification part in haloalkanes and haloarenes, I already told you that the same type of classification we followed in the case of alcohol, right? Only instead of halide we are using the term alcohol. So there is a kind of the repetition of properties or the repetition of chemical reaction is going to occur. So very simple, you try in a simple manner. So student, first of all I am going to start with the preparation from alcohols. So students, with the help of alcohol we can form alkyl halide in following 6 ways. And if you see the first reaction where alcohol is treated with HCl acid in the presence of zinc chloride, it gives alkyl chloride plus H2 as a byproduct. As from this first reaction in the alcohol chapters, alcohol phenol ether chapter, is used as a chemical test reaction, right? Actually this mixture of HCl and ZnCl2 is called a Lucas reagent, and which we are going to use as a distinction test between primary, secondary and tertiary alcohol. So I already told you that the reaction which we are using in preparation, somewhere it is used as a chemical reaction or chemical properties, right, or the distinguished reactions, right? So the first reaction here we use as a preparation, and in alcohol phenol we are used as a going to use as a distinction reaction. The second reaction where alkyl bromide is formed, then PX3, X is especially Cl we can use or Br we can use, then reaction of alcohol with PCl5, then reaction of alcohol with red phosphorus in the presence of X2. Here X2 is either bromine or means Br2 or I2. So X is Br or I. So either red phosphorus is treated with Br2 or I2 to gives either alkyl bromide or alkyl iodide. Now at last alcohol is treated with SOCl2 to gives alkyl halide, SO2 and SCl. Okay students, so this is the first method. Now after that we are going to discuss with the second one, that is called Sandmeyer reaction. Student, in Sandmeyer reaction it is of based on two parts. Two parts means, first of all, in the first part there is a discussion of preparation of diazonium salt, which is the we can say the starting material, starting compound which is required for Sandmeyer reaction. And with the help of Sandmeyer reaction we can form aryl halide, that is chloride or bromide especially, right? So in the first part, that the first reaction is for the preparation of diazonium salt. Now what is the statement? When primary aromatic amine is treated with NaNO2, right, that is the sodium nitrite, and halogen acid, it gives benzene diazonium halide, that is called diazonium salt. And this method is also called diazotization. Now for Sandmeyer reaction, this diazonium salt is treated with cuprous, chloride or bromide to gives aryl halide, especially chloride or bromide, and nitrogen as a byproduct, right? But student, you can see in this Sandmeyer reaction with instead of like Cu2X2 here only Cl and Br. But if you want to attach iodine, then we can treat diazonium salt directly with Ki, that is with potassium iodide, so it gives aryl iodide. Okay students, so this is the method for the preparation of aromatic halide, that is the aryl halide, chloride, bromide and iodide. For chloride and bromide we treat diazonium salt with cuprous halide, and for iodide it is treated with potassium iodide. Now the other method is for the preparation of alkyl halide, that is halogen exchange method. It's simply we can say it's a double displacement type reaction students, right? When alkyl halide is treated with sodium iodide in the presence of dry acetone, it gives alkyl iodide plus NaX, that is X is either Cl or Br. Means if you start with RCl, then the byproduct is NaCl. If you start with RBr, then the byproduct is NaBr. Student, this reaction is called Finkelstein reaction. It is one of the name reaction, is very much important. Many times this question is asked in a competitive exam also. Now another name reaction is Schwarz reaction. It's very simple. It is the process for the method for the preparation of alkyl fluoride, right? where it is based on the synthesis of alkyl fluoride. Okay, so when alkyl bromide is treated with, chloride of bromide is treated with in the presence of metallic fluoride, and these metallic fluorides are such as AgF, SgF, COF2 or SbF3, then it gives alkyl fluoride and one byproduct, right? If you start with like fluoride and alkyl bromide, then the byproduct is, if it is suppose silver fluoride, so the byproduct is silver bromide. Student, if you see both the reaction, it is simply based on double displacement reaction, yes or no, which we studied in class 10. So it's very simple, right? Students, see one more thing, this is a very common and important, it always making a disturbance, right? There is a confusion, we can say, when we are going to ask Frankenstein, many times students write Schwarz, and for Schwarz many times they write Frankenstein. So better you just see, in Frankenstein reaction the starting alphabet is F. So here in the attachment we can very simply say that fluorine is not going to attach, right? If it starts with F, so fluoride is not going to form, iodide is going to form, and then rest is Schwarz. So obviously there is no F, so it starts with it forms fluoride. Okay students, so these are up to the preparation part. So first we discuss with the alcohol related, second Sandmeyer, then it is halogen exchange. Now student, after this preparation part, the next topic is physical properties. Now in physical properties, the first topic is melting and boiling point. See how melting and boiling points are going to increase or decrease of different alkyl halides. So based on that, there are some categories, there are some variation. The first is based on mass. When the mass of alkyl halide increases, then melting and boiling point increases, as well as if size is going to increases. Size means if the size of halogen atom is going to increase, definitely its mass is also going to increase. That means its melting and boiling point is going to increase. Okay students, so this is the first category. You can see from the second paragraph, the order is also given. If suppose alkyl group is fixed and halogen is going to variable, so very simple, if carbon is fixed, halogens are different. So from fluorine to iodine, iodine having the size, greater size, as well as the maximum mass. So the order is Ri, Rbr, Rcl and Rf. Okay, and this is because with the increase in size and mass of halogen atom, the magnitude of van der Waals increases. So when the magnitude of van der Waals increases, the melting and boiling point also going to be increased. Okay students, the first one based on size and mass. Second is for the isomers, right? So in the case of isomers, especially structural isomers, what we observe, we face or we see or we observe the different structure, right? So in that different structure, there is a change in branches and long chain, right? So very simple, what is the effect of branching on melting and boiling point of alkyl halide or aryl halide? The very simple answer is, when branching increases, melting and boiling point decreases. Melting and boiling point decreases. Okay students, you can see for bromobutane, it's a straight chain, surface area is more. When there is only one branch, that is when bromine is going to attach to second position, its boiling point is going to decrease. Again for 2-bromo 2-methyl propane, it's the lowest boiling point. Okay students, so this is the category based on melting and boiling point. After that there is a topic density. For density students is very simple, density is mass per unit volume. So mass increases, density increases. Okay students, and with solubility, if you discuss about the solubility of alkyl halide and aryl halide, is very simple, it is less or is strongly soluble. Because mainly the solubility of any solute depends upon the nature of bond, right? A very simple concept, like dissolved like. Okay, so here the alkyl halide and aryl halides are the non-polar solutes, so it cannot dissolve in polar solvent, that is water. Yes, they can dissolve in organic solvents such as benzene, acetone, chloroform, etc. Okay, so in this video I completed till physical properties. Start with the nature of CX bond, then preparation of alkyl halide, and then the physical properties. Okay, so student, in the next video I am going to start with the topic that is the chemical properties and the chemical reaction, where I am going to start with the nucleophilic substitution reaction, its type, right? In class 11 you already completed a type of reaction, right, where mainly the types are like addition reaction, substitution reaction, right, elimination reaction. See students, in chemical properties, actually I just want to give a highlights on this type of reaction. In any organic reaction, right, or any organic reactions are mainly based on in these three categories, that is addition reaction, substitution reaction, and elimination reaction. Later on you can discuss about their types and all, but mainly the type of reactions are only of these three, right? In addition reactions, if you want to observe that what kind of reaction is occur, so very simple, you just see the reactant, right? And if the reactant is unsaturated hydrocarbons and it's going to convert into saturated, then definitely the reaction is based on addition. Now in the case of elimination reaction, if the reactant is saturated and the product which we obtained is unsaturated, is definitely elimination reaction. And in the case of substitution reaction, in reactant and product side, both having the saturated compounds, only there is an entrance of, we can say, a new constituent from one side and the removal of one. Okay students, so whatever the reaction we are going to follow in our organic chapters, they must be all are based on these three reaction. And in this chapter mainly we are going to discuss about the substitution, that is the especially nucleophilic substitution, and elimination reaction. Okay, and I am also going to give the assignment till this topic, okay, which you can also get from the study material side, and our school is also going to provide the link also. Okay, thank you.